All right, guys, so here we are. We're going to do lesson 6.5, linear inequalities. A linear inequality is basically kind of like slope-intercept form, except this time we're going to have greater than, less than, greater than equal to, less than equal to, that type of thing. So the first test that we have to do in problem 1 here is we are being asked to tell if an ordered pair is a solution of a given inequality. So right here for part A, they give me the ordered pair 1, 2. We know that every ordered pair is x and y. And so to figure out if that's a solution, all we're going to do is we're going to plug it in to this inequality. My inequality is y is greater than x minus 3. So where I see y, I'll put the 2. Where I see x, I put the 1. From here, I'm going to simplify. 2 is greater than, well, 1 minus 3 is negative 2. So 2 is greater than negative 2? Yes, that's true. So therefore, we would say yes, that ordered pair 1, 2 is a solution to that inequality. Pretty easy. Okay, we're going to do the same thing over here for part B. If you take a look at part B, we have the ordered pair is negative 3, negative 7. So there's my x and there's my y. This is my daughter Zoe here. You can hear her. She wants to draw and do linear inequalities at all of 3 years age. Hold on. So this time for part B, where I see y, I will plug in a negative 7. Where I see x, I will plug in a negative 3. And then all I need to do is simplify. And so we get negative 7 is greater than negative 6. And that is false. Negative 7 is not bigger than negative 6. So this is not a solution to that linear inequality. Hope that makes sense, guys. Okay, so here's one for you guys to try. You can take a moment and try it. I'm also going to work it out side by side with you. So we have our ordered pair 3, 6. That's my x and y. We have my inequality to see if it's a solution. Where I see y, I'll plug in a 6. Where I see x, I'm going to plug in a 3. So probably one of the most challenging parts of this problem is right here to do 2/3 times 3. And if you remember what I've said, if fractions trouble you, do the work off to the side. 2/3 times 3 is the same thing as 2/3 times 3 over 1. We multiply fractions straight across, so we get 6 over 3, which is just a 2. So now when I go back into my regular problem, it's just 6 is less than or equal to 2 plus 4. 2 plus 4 is 6. So 6 less than or equal to 6, that's true. And so we would say, yes, that 3, 6 is a solution to this problem. Okay, moving into problem 2. This time we're going to be graphing an inequality in 2 variables. Well, if you remember what I was saying at the beginning of this lesson, this looks a lot like y equals mx plus b. So you know what? We're going to treat it just like it is y equals mx plus b. Pretend it's really identical. The only thing we're going to do differently is at the very end. And so I'm just drawing my little coordinate plane here. When I'm looking at my inequality, I can see right away that my slope, my slope would be 1 or 1 over 1. Remember, there's always a 1 in front of that x. All right, so I'm going to put my little 1 there so you can see where that came from. My y-intercept would be a negative 2. So as far as graphing this goes, I'm going to begin on the y-axis at negative 2. And then from there, my slope is positive. So remember, slope is rise over run. That means from that point at negative 2, I'm going to go up 1, right 1. So I'm going to put my second point here. And then here is where things become a little bit different with an inequality. We first have to ask ourselves, are you going to do a dashed or are you going to do a solid line? That's really question number 1 to ask. Here's how I figure it out. If I have a less than or a greater than symbol, I do a dashed line. If I have a less than equal to or greater than equal to, I do a solid line. In this case, I just have a less than. You can see my inequality symbol is just, or sorry, it's just a greater than. So I'm going to be doing a dotted or a dashed line instead of drawing a solid line. Okay? Now, the second thing that we have to ask ourselves, so question number 2, is going to be above or below. And this is pretty easy, guys. If it's any type of greater or greater than equal to, we would shade above the dashed or dotted line. If it is less than or less than equal to, we will shade below. And so again, my inequality symbol is a greater than. So that means I need to shade this thing above the inequality line. And so above my line is going to be right on this whole side. And that is going to be my answer. Okay, so here with this got it number 2, we just have an opportunity to practice this again, graphing an inequality. So I will go ahead and begin with just drawing a basic coordinate plane because again, I'm just thinking about this like it's y equals mx plus b. And so when I think about it like that, y equals mx plus b, I'm easily able to identify my slope is 1 over 2. There's my rise over run. My y-intercept is 1. And so I'll begin graphing and plotting my points just like usual. Start with 1 on my y-axis. My slope is positive 1 over 2, so up 1 over 2. And there will be my second point. Okay. And then now becomes the first question. So first question is, should we go with dashed or should we go with solid? To figure that out, guys, I've got to look at my inequality symbol. This inequality symbol is a less than equal to. Dashed is less than or greater than. Solid is less than equal to or greater than equal to. So in this case, I've got to go with a solid line. So I'll connect my 2 points with a solid line. And then that brings me to my second question. The second question is, should we shade above or should we shade below that line? So if you look at your inequality symbol, you have a less than equal to. That would be below. Below is anything less than, and above is anything greater than. So this time I want to shade everything below that line. And so it's going to be really everything down here in the coordinate plane is going to be part of my answer. We're shading all below the line. Okay, guys, this time we're going to still be graphing linear inequalities, but these are in one variable. One thing that I've taught you that hopefully is coming to mind right now is our good old Hoy-Vux. So right here for x is greater than -1 for part A, the first thing that's coming to mind is my VUX. X goes with the V, which lets me know this is going to be a vertical line. So to graph this on my x-axis, I'm going to go to -1, and I am going to put an ordered pair. Now, I know it's going to be a vertical line. However, I still need to go back because it's an inequality, and I have to think, should I go dashed or solid? And hopefully you know the answer to this at this point, but we are going to be going dashed. The reason I'm going dashed is because I just have a greater than. Remember, dashed is greater than or less than. Solid is less than equal to or greater than equal to. So for part A, I'm going dashed. Now, here's what's a little bit tricky. Because for a vertical line, there really is no above or below. We only have a left or a right. And what this is saying on part A is x is greater than -1. Well, if there's -1, there's 0, 1, 2, -2. I have to think in my mind, where are numbers greater than -1? Numbers greater than -1 occur to the right of this inequality symbol. So for a vertical line, we would think that if it's a greater than or greater than equal to, we will go right. And for a vertical line, if it's less than or less than equal to, we would be going left. Okay? Switching gears to part B, we have a y is greater than equal to 2. So immediately I know, hey, I've got to get over to the y-axis, head to positive 2, put my point there. It's going to be a horizontal line. Remember, with my good old HOI, the y goes with h, which is horizontal. But I've got to look at my inequality because my inequality symbol tells me if I should go dashed or solid. This one is going to be solid because we have a greater than or equal to. So I want to put a solid horizontal line. And with a horizontal line, you definitely have an above or below. This is a greater than. So greater than is going to be shading above this line. So I would shade everything up above. Okay. All right, last one for you guys to take a peek at. Same stuff. Hoy bucks is coming into play here. So remember, that's how I know if it's horizontal or vertical. For this first one, x is less than -5. That means on my x-axis, I want to go to -5. I will go ahead and put a point. Before I make the line, I've got to ask myself solid or dashed. So one more time. If it's a less than equal to or greater than equal to, it's solid. If it's just less than or equal to, it's dashed. So that's the first kind of decision that we need to make. In this case, since we are just looking at a less than, I'm going to do a dashed, or sometimes they call this also a dotted line. Okay. Now, we have to decide where it is less than -5, because that's what this is saying right here. It wants numbers less than -5. Well, if you look at your number line, this would be -4, -3, -2. Over here, -6, -7. Numbers that are less than -5 happen to the left. This is the one that's tricky, these vertical lines. So we would really fill in everything to the left of that dotted line. Okay, part B, let's move over to there. We've got y is less than or equal to 2. So on my y-axis, once again, like on the previous one, we're going to go to 2. We're going to put a point. Since this one is less than equal to, you can see I'm just looking back at my inequality sign. That means it's going to be a solid horizontal line. And since it's less than, I will be shading everything below that line. Okay, class, so as a final little recap of everything, when we graph inequalities, the first choice you have to make is if you should go with a solid line or if you're going to go with a dashed, or sometimes they call this a dotted line. The way I figure this out is I have to look at my inequality symbol. Less than equal to or greater than equal to is solid. Less than or greater than is dashed. After I figure out that, then the second thing I've got to decide is if I should shade above or below the line. And so I look again at my inequality symbol. If it's any type of greater than, meaning greater or greater than equal to, I shade above. However, if it's a less than or less than equal to, any type of a less than, we shade below. Okay, I hope this helps, guys. Your assignment for today, for this part, for for 6-5, sorry, is going to be IXL T1 and T3, both of those to 80%. Okay.